Hi friends, welcome to GMKTutorials. In this video, we have to see about the leakage power minimization. Generally, let us see, in case of the previous sessions, we discussed regarding the low power techniques. So how we are reducing the supply voltage and what are the consequences if you are reducing the supply voltage, what are the benefits, that means in terms of delay what happens is there, as well as in terms of performance how it affects the corresponding supply voltage scaling, as well as how the power dissipation is decreases. That is completely discussed in the third unit, that is nothing but supply voltage scaling. As well as in case of the fourth unit, that is generally called as a leakage switching capacitance minimization, how the switching capacitance plays a very important role in terms of reduction of the supply voltage. And third and most important thing is nothing but a leakage power minimization. If you are reducing the leakage power, obviously what is the effect of power consumption in the corresponding devices. So let's move on to the topic. So ఇప్పటివరకు ఎవరైనా మన ఛానల్ ఇంకా సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే సో ప్లీజ్ సబ్స్క్రైబ్ అవర్ వీడియోస్. సో ప్లీజ్ వాచ్ ది ఎండ్ ఆఫ్ ది వీడియో, ఎందుకంటే ప్రతి ఒక్క చాలా ఇంపార్టెంట్ పాయింట్స్ ఆ వీడియోలో ఉంటాయి. మనం స్కిప్ చేసామంటే ఆ ఇంపార్టెంట్ పాయింట్ మిస్ అవుతాం అక్కడ. సో ప్లీజ్ లెట్స్ వాచ్ ది టిల్ ది ఎండ్ ఆఫ్ ది వీడియో. సో లెట్స్ మూవ్ ఆన్ టు ది టాపిక్ ఫర్ టుడే. సో దట్ ఈస్ నథింగ్ బట్ VT CMOS. So VT CMOS is nothing but a variable threshold CMOS complementary metal oscillator. How this VT CMOS is very helpful for reducing the supply voltage. That is nothing but reducing the leakage current. That is very important. Generally, we know that the supply voltage, low supply voltage along with the low threshold voltage provides a reduced overall power dissipation without degrading in the performance. So you know guys, generally if you are reducing such a kind of the problems, obviously another consequence will be there. That is nothing but, suppose if you are reducing the supply voltage in that fashion, what happens is that the use of low VT transistors increases the leakage current. That means if you are reducing the low threshold voltage, obviously the consequence is that increasing the leakage current. If you know the leakage, if you increasing the leakage current, obviously overall static power dissipation is increases, right? So that is the one of the most important problem, because of, you know guys, P is equal to VI. Okay, P is equal to VI. That means if the current is increases, means that obviously overall power dissipation is also increases. That is a basic problem. So in many recent applications, such as if you go for real-time applications like cell phones, personal laptops, or any devices, that all devices in the most of the time in the standby mode. In the standby mode means that we are not performing any kind of operation on the corresponding devices. It may be laptops or mobiles. At that time, the most of the power dissipation is happens in case of such a kind of the devices. So it is one of the most drawbacks, because of in the standby mode most of the energy is drawn from the battery, means that obviously the battery life is also decreases. That is the most important point. So for that purpose, how these techniques are going to be helpful for us. Let us move on to the next one. So the VT CMOS circuits are based on the principle of body effect. If you are reducing the corresponding sub-threshold leakage current when the circuit is in the normal mode of operation, as well as the threshold voltage is also a function of, as well as the threshold voltage is a function of voltage difference between the source and drain. Generally, threshold voltage means that the amount of minimum voltage is required to form a channel between the source and drain terminals, right? So if you want to make a channel between the source and drain, how much voltage is necessary for creating a channel in the corresponding under the gate terminal? That is the basic thing, right? That gate voltage, minimum gate voltage, is generally called as the threshold voltage. I think this was already discussed in the previous sections, right? As well as the substrate terminals of the all n-channel metal oxide terminals are connected to one potential ground, as well as P is also connected. So the basic thing is nothing but just you have to take the corresponding n-channel and p-channel substrate materials are take outside of the corresponding transistors, we can make another circuit, useful circuit, that will be discussed in a few seconds later. Let's move on to the next one. So this is nothing but a body bias. This is a general structure of the CMOS circuit. Generally, CMOS circuit means that it consisting of a two terminals. One is nothing but a PMOS circuit and second one is nothing but a NMOS circuit. So let us see, generally this is the initial scenario. That means here source and substrate. This is a substrate terminal. Okay, this is a substrate. This is nothing but a source terminal. Okay, this is a source and the substrate terminals are connected to ground here. So biasing means that here source terminal is connected to the ground and we are applying some suitable voltage to the corresponding substrate. In case of the P-type substrate as well as in case of the N-type substrate is also we are providing the biasing. That means if you are providing such a kind of the biasing voltage to the devices, obviously which affects the threshold voltage of the corresponding device. That key point is very useful for us in case of the variable threshold CMOS technology to reducing the leakage power in the corresponding circuit, and overall we are attaining the minimum power dissipation in case of the standby mode. So that is nothing but the source and drain diffusion regions are always in the reverse biased. That point is already discussed in the static power dissipation already in the previous classes. So with respect to the source substrate, that means the threshold voltages of the transistors are not significantly affect the influence the body effect. Okay, as well as in case of the VT-CMOS circuit, the substrate bias voltage of the NMOS and PMOS transistors are controlled with the help of another circuit, that is nothing but a substrate bias control circuit. So that is we will discuss in the next show. Let us see in this figure. So this is the circuit diagram for the corresponding VT-CMOS, variable threshold CMOS circuit. So this is a basic circuit for this one. So this is in this circuit diagram what happens is that, so this is the VT-CMOS circuit diagram. So here this is nothing but a substrate terminal. This is the P-type substrate. This is generally called as a P-type. So the PMOS substrate is taken to the outside as well as NMOS substrate is also taken to the outside. So that means if you want to apply the different suitable voltages to the corresponding P-type substrate as well as N-type substrate, just you have to take that two leads to the outside. We can design another circuit. That suitable circuit is used to apply the different biasing voltages to the P-type substrate as well as N-type substrate. This circuit is generally called as substrate bias control circuit. That means the name itself represents substrate bias control circuit. That means we are applying the biasing voltages to the PMOS substrate as well as NMOS substrate with different voltages. That different voltages are very important in case of the VT-CMOS. So that is generally outside of the corresponding chip, or it may be internal part of the circuit also. Let us move on to the next one. This is a basic diagram for the VT-CMOS circuit. So VT-CMOS, they were taking the one inverter, that is nothing but CMOS circuit. The CMOS circuit consisting of one P-type CMOS as well as another one is nothing but N-type CMOS. Just we are taking the substrates of the corresponding PMOS as well as NMOS transistor to the outside. We can designing another circuit, that is nothing but a substrate bias control circuit. That substrate bias control circuit is used to apply the different voltages to the PMOS circuit as well as NMOS circuit. What is the need of these different voltages? That will be discussed in a very few seconds. Okay, let's move on to the next one. So let us see, in case of the VT-CMOS, generally we have two types of modes is there. One is nothing but a active mode and second one is nothing but a PMOS transistor. So active mode and second one is nothing but a active mode. So second one is nothing but a standby mode. So what is meant by active mode? Active mode means that it's a normal operation. So let us see, in case of the NMOS transistor and PMOS transistors are VBN. VBN is nothing but NMOS transistor substrate voltage is 0 voltage as well as the PMOS transistor substrate voltage is VDD respectively. Let us assume like that. Suppose if the supply voltage is 1 volt, at that time threshold voltage of the NMOS transistor is 0.2 and the threshold voltage of the PMOS transistor is 0.2. So let us see here very closely. these threshold voltages are very small. That means these two transistors supply voltages are threshold voltages of these two transistors are very small. If you are applying the low threshold voltage means that we are maintaining the high performance. That is very important point here. That means if you are applying the low threshold voltage means that we are maintaining the good performance in the circuit, or maybe speed of the circuit is also very good. Second thing is nothing but a standby mode. In case of the standby mode, the substrate bias control circuit generates a low substrate, that is nothing but a numerical values is there, that is nothing but a threshold voltage of the substrate voltage minus VB and minus V, and Vp is equal VB plus Vp for PMOS transistor, right? So let us assume that in this scenario, this leads to increase in the threshold voltages for NMOS transistor as well as PMOS transistor. That means the threshold voltages of the NMOS and PMOS transistors are increased to the 0.5 volts from 0.2. So if you are increasing the threshold voltages means that what happens? Let us see. This term, by increasing the threshold voltage of the both the transistor, the substantial reduction in the leakage current. That means if you are increasing the threshold voltage, the leakage current is decreases. As the leakage current is decreases means that overall power dissipation is also decreases. Why? Because the leakage power is the exponentially depends on the sub-threshold depends on this sub-threshold voltage. So that's why the leakage current is decreases. As well as one more important point is nothing but for every 100 millivolts rise in the threshold voltage, the sub-threshold leakage current is reduced by the half. That is also very important point, right? So these are some of the important points. Let's move on to the next one. Although the VT CMOS is a very effective technique for controlling the threshold voltage and reducing the leakage current. Yes or no? That means if you are applying some suitable threshold voltage which maintains the performance as well as overall power dissipation is also. So it requires a twin well or triple well CMOS fabrication technology so that different substrate biases are applied for the different chips or parts of the chip. So that is also very little bit complex for us. As well as separate pins are maybe designed for the corresponding substrate bias controlling circuit. That is somewhat difficult as well as it is a cost effective because of we have to routing the corresponding lead terminals from the corresponding substrate. Usually the additional area is required for the substrate biasing circuit, but if you compare this circuit size, it may be very small compared to the overall circuit shape. So that's why we can neglect the corresponding area penalty in case of the VT CMOS because of we are maintaining the most important parameters is nothing but leakage power is reduces, therefore overall power dissipation decreases, as well as by maintaining the low threshold voltage we are maintaining the good performance. Speed is also very good, as well as by increasing the threshold voltage we are decreasing the leakage current. That consequence is also effect on the power reduction in the corresponding circuit in the standby mode condition. That is nothing but very advantageous. So it is a very important and most important topic for VT CMOS circuit point of view. Okay, just I will wind up the session with Telugu within 2 minutes. So basically VT CMOS circuits ante enti variable threshold CMOS circuits. బేసిక్గా మనం ఈ వేరియబుల్ థ్రెషోల్డ్ సర్క్యూట్లో 2 types ఆఫ్ థ్రెషోల్డ్ వోల్టేజ్ మెయింటైన్ చేస్తాం. ఒకటి లో థ్రెషోల్డ్ వోల్టేజ్ అండ్ సెకండ్ వన్ ఈజ్ నథింగ్ బట్ హై థ్రెషోల్డ్ వోల్టేజ్. ఈ లో థ్రెషోల్డ్ వోల్టేజ్ ఏం చేస్తుందంటే బై అప్లయింగ్ ది లో థ్రెషోల్డ్ వోల్టేజ్ వీ కెన్ ఇంక్రీజ్ ది పర్ఫార్మెన్స్. బై ఇంక్రీజింగ్ ది థ్రెషోల్డ్ వోల్టేజ్ వీఆర్ డిక్రీజింగ్ ది లీకేజ్ కరెంట్. సో లీకేజ్ కరెంట్ తగ్గిస్తున్నా ఉంటే పర్ఫార్మెన్స్ అనేది ఇంక్రీజ్ అవుతుంది. if you are decreasing the leakage current means that leakage current తగ్గించారంటే overall power dissipation తగ్గుతుంది. If you are increasing the threshold voltage means that obviously leakage current తగ్గుతుంది, that consequence is nothing but power dissipation decreases. If you are decreasing the threshold voltage, what happens is that the performance of the circuit is also increases. Therefore, if you want to design any circuit in the real world, we are maintaining good performance with less power consumption. That is the basic objective of any circuit, right? So that can be achieved with the help of a VT CMOS circuit. So just we are taking the how biasing can be achieved with the help of some suitable voltages to these two circuits. This is nothing but initial diagram. This is nothing but by applying some suitable voltage to the biasing of the substrate of the PMOS as well as NMOS circuit, we can maintain the corresponding suitable voltage that leads to increasing or decreasing in the threshold voltage in the circuit. Okay, This is the circuit diagram for the VT CMOS circuit. Just we are taking the substrates of the two LEDs from the outside. Okay, then we can make one circuit designing. We are designing one circuit. The designing circuit is generally called a substrate biasing circuit that can be controlled. Circuit is used to control the different different voltages are given to the corresponding substrates of the PMOS as well as NMOS. So this is a normal mode of operation and as well as standby mode of operation. What happens in the standby mode? In the standby mode configuration, the threshold voltage is increases, therefore the NMOS transistor and PMOS transistor leakage current decreases, therefore overall power dissipation decreases. Moreover, for every 100 degrees millivolts increase in the threshold voltage, the leakage current is also decreases by half. That is also one of the most important point for us. So this is this area, and so in the next class we discuss regarding the